Hey everybody and welcome back. Today we're on the 6th episode of our journey and we're going to deploy Traefik with valid SSL certificates automatically deployed, and we're going to spin up PiHole as our first example of an application that's going to be using our Longhorn storage. So this is quite a big one, and by the end of this video you should have all of the building blocks in place to be able to go and extend your cluster to host all of your applications that you're already hosting with things like Docker. Now, thankfully, I've created another script to make this simple, but we're obviously going to go ahead and walk through this script ahead of deployment. Obviously, if you don't feel comfortable with running scripts, etc., you can look inside the script and you can see every single command that it's going to do, and you could just run those manually if you wanted to. So let's jump into the script, have a look at what it does. Then there's a couple of things we need to tweak in our existing cluster, and we'll do that through Rancher, and then we should be in a position to be able to deploy the script and get all of this up and running. So over on my GitHub, you're going to find all the files you need. So here is the script that we're going to run, and these are the two folders with all the files that we need to configure. Now we're going to do Traefik first, and then we're going to get onto PiHole. So let's jump into Traefik, and you'll notice that there's quite a bit going on here. That's because we need to set up a number of YAML files before this will work. And you're going to need to go through each of these files and configure it for your setup. Thankfully, that should be as simple as just copying a lot of the variables from your existing Docker Compose files over, and it should work. So the first thing we're going to look at is the values file for Traefik. That's because we're going to deploy this with Helm, and we're going to put our values in the values.yaml, which will overwrite the default values.yaml if you don't put your own in. So what does this look like? Well, inside we've got some global arguments. We're just going to say that we don't want to send anonymous usage stats, and we don't want to check for a new version. You can change that as you see fit. We're going to allow it to skip insecure certificates, so that's going to be needed for some of our backend services where we're routing it from things like our Traefik with SSL through to things like, I don't know, the PiHole GUI, which will be running on port 80. We want the log level to be info. Again, you can change that to debug if you want, but it's going to get pretty noisy. After that, we get onto the deployment itself, and this should be straightforward. So it's enabled, and we want 2 replicas. That means we're going to be running 2 instances of Traefik at any given time, or Kubernetes is going to try and maintain 2 copies. And that's good because we've got 2 worker nodes. You can change this to however many worker nodes you've got, so just change that as you see fit. The rest of it is all in default. Next, we're going to set this to be on the node selector of worker true. Now that's something we need to do in a moment, and I'll show you how to do that. But effectively, this is going to pin Traefik to our 2 worker nodes. And typically you would provision these nodes to have more CPU and more RAM to accommodate for doing all of the heavy lifting. And if you wanted to, you could put 1 worker node on 1 physical machine and 1 on another if you wanted to split your cluster across 2 physical machines, or more if you've got more. The next bit is pretty straightforward from previous Docker deployments. We want to have 2 ports, so we're going to have web and web secure, and these are already defaultly assigned to 80 and 443, so we don't need to change it. If you wanted to add more ports here, you would simply add it to this section along with the port number. Next is an ingress route. Now this is a new term, but it's basically the route that you have your ingress, so how Traefik is going to come to this service. So within Kubernetes, you set up a service, so you say something's listing on port 80, then you set up an ingress route to say, hey, from external, you can reach that service, a bit like a port forward. We're not going to be using that, and you might think, why? Well, because ingress route is a terminology from Kubernetes, and actually we want Traefik to be doing the ingress for us, and we'll come on to that in a minute. We want to create a Kubernetes CRD, so that's a custom resource definition. We want that to be enabled so we can specify some custom variables. In this instance, we're going to be calling the ingress class Traefik external because this is for external access to Traefik, so it kind of makes sense. We're going to allow external name services to true. We're going to have Kubernetes ingress enabled to true, allow external name services, and publish services enabled false. Don't worry too much about what those are. Those are just some of the default variables to get this working. You can read all about those variables on the Traefik website, but leaving them as is will get this up and running for you. We want role-based access control to be enabled, so similar to how we did with Rancher. And then here's the service that I mentioned earlier. So this is where you expose your service, i.e. Traefik, and you specify the ports and the load balancer IPs, etc. and then we'll create an ingress to this with Traefik in a moment. So we want to enable the service. It's going to be a type load balancer, and we saw before with kubevip, if it sees a type load balancer, it's going to assign it an external IP. And in this instance, I've just manually chosen an IP address from my kubevip range. So you need to change this IP address to something in the range you specified, and that means that all traffic going to your reverse proxy is going to be reaching this IP. So in your existing firewall rules, you've probably got it pointed to your Docker VM. You need to change that to whatever this IP address is here. The next bit, which is really important, is the external traffic policy set to local. So that means that Traefik is actually going to see the real IP address of something accessing this machine. And that's really helpful for things like CrowdSec. Otherwise, it's not going to know where the IP address came from, and therefore it might not be able to block it based upon its known bad IP list. Once we've done that, we're going to head back and we're going to look at some more variables. So back in the Traefik folder, we've got the default headers. And the default headers are a middleware which we need to configure to access Traefik. So we've called it a kind middleware. We're putting it in the namespace Traefik, and the script is going to create that for us. Then we've set some header variables. So don't worry too much about these. These are all things that you'll have seen in the Docker implementation anyway. Just leave them as is. You won't need to edit this. Next, we want to set up the dashboard for Traefik so you can see all of the fancy stats within your Traefik instance. So if we look in here, we've got 3 files. We've got the ingress, and that's the bit I mentioned earlier. So this will point to the service that we've created. So we create an ingress route. We've given it a name of the Traefik dashboard. It's in the same namespace as Traefik, so it has access to everything it needs. It's going to use that Traefik external class that we just defined a moment ago. It's going to enter on web secure, so port 443. And you want to specify here what you want the URL of your Traefik dashboard to be. So you don't know my domain, so make sure you change that. And then at the bottom, it's really important. You need to specify the certificate name it's going to use. So mine is Jim's Garage-TLS. If you want to do a similar naming convention, just change this to your domain here. And when we get onto future files, you need to make sure that you reflect this name in those files. So heading back to dashboard, we'll look at the middleware. And then again, this is just a piece of middleware that says it's going to use a secret. So when we access the dashboard, the password for the dashboard is actually stored as a secret. And this is just saying that we've got a secret called basic auth and we're supposed to use that one. So going back to the dashboard, here you can see that secret we've just spoken about. So if we click on this, we've created a secret. Now this is just basically a password stored within Kubernetes. And because we're using Cert Manager and Secrets Manager, it's shared across all of our HA nodes. So this here you want to change, and you want to use HT password again to generate a base 64 encoded password. But if you just want to get this up and running, this is just using admin and password. Now that we've completed the dashboard, let's go back to the Traefik folder, and you'll see that I've put Cert Manager within this folder. Now that's a little bit confusing, but it's just because we need to make some changes to Cert Manager to get Traefik up and running. Now that's quite simple. We need to go into the values file. So remember, we're deploying Cert Manager with Helm, and it takes a values file. So instead of the default which we used last time, we need to specify something more specific. So in this one, we don't want to install the custom resource definitions. Now, if you remember back to the previous video, we did that manually with a kubectl command. So those are already there, so we don't need to install them again. We want 3 replicas, so I've just made sure that this is available across all my HA master nodes. And then we need to add some DNS resolvers. Now this is important because when we come to generate the certificates for our Traefik instance, it needs to know where to go and challenge it and prove that you own this DNS record. So I've just done quad 1 and quad 9, which is Cloudflare and quad 9. You can choose whatever you want to here. It doesn't really matter as long as they're valid. I suggest you just leave them as default though. Coming back into the root of Cert Manager, you can see that we've got 2 additional folders. So we've got certificates folder with a certificates production YAML file. So this is how your certificate is going to be based upon that CRD. So this is going to deploy a file of type certificate, and it now knows because of that custom resource definition what a certificate should look like. And it's just going to give it a name. Again, change this to your domain. change the secret name, and this is the bit I mentioned earlier where we referenced it within the ingress. This is the bit you need to change here to match that. It's going to be of type let's encrypt production. It's going to be a cluster issuer, and it's going to have a common name. And all of these here, you simply need to change these to your domain. Make sure you do that, otherwise you're going to run into issues. Going back to Cert Manager, we have the issuer. So what's an issuer? The issuer is the entity that's going to issue your certificate. So let's go into let's encrypt. And you can see that we've set up all the details here for it to go and do a DNS challenge with let's encrypt. Now, this is pretty much identical to how Docker works and did it. It's just the file format is slightly different. So here we're creating a cluster issuer. So a type of file called a cluster issuer. It's going to be called let's encrypt production. If you look at the official documentation, you're actually meant to do a staging certificate first. But given that I've provided this in a script form, and as long as you follow these instructions to change it, there's less chance of you getting it wrong. You could also copy your existing certificate from on your Docker host if you wanted to, but I recommend you run this script. So it's going to go off to let's encrypt, and it's going to do a standard DNS challenge just as we did within Docker. Just remember that you need to add your email address here, and you're going to need to add your token, which we'll refer to in a minute. And at the bottom, you need to change your DNS zone as well to your DNS zone on Cloudflare. So this is using Cloudflare. If you're not using Cloudflare, you'll need to tweak this a little bit to your domain registrar. So going back to the issues folder, you can see that we've got the secret CF token. Now that's secret Cloudflare token. And that's the token I was just talking about in the previous file. So you need to go into your Cloudflare and you need to get your API token. Again, remember, this isn't the global API token, it's just the API token. Once you have that, you need to paste it here and then save this file. Don't worry, you don't need to download any of these files from GitHub like this. The script will automatically do it for you. So now that you've amended all of those files for Traefik, you should be in a good position to get this up and running, but the script is also going to set up PiHole for you as well. So let's have a quick look at that. And I'm going to put this in the manifest folder, and you'll see that when you run this script, it's going to create two new folders, /helm and /manifest, and the manifest files for this are in here. So I've created 3 files for this, and actually the deployment actually contains a few YAML files because you can use delimiters to put multiple files within the same one. Hopefully by now you should see some similarities though. There's an ingress, there's a default headers, and then there's a deployment YAML. So let's look at the deployment first. Now the deployment's quite straightforward. It first creates a namespace called PiHole, because as I mentioned in the previous video, we want all applications to be deployed in their own namespace so that we can put granular controls around namespaces and underlying applications and services, etc. Then, because of the 3 dots, this could actually be a separate deployment.yaml file, but within this deployment.yaml file, I basically just copied and amended the existing setup that we had within PiHole Docker. So this is automatically going to use Cloudflare Tunnel to route your requests over a DNS. So by default, running the script, you're going to get DNS over HTTPS. So what's it doing? Well, it's creating a deployment, it's calling it PiHole, and it's giving it an instance name of PiHole. These are all just labeling techniques for Kubernetes. Then we come on to the specification of the deployment. Now, I've only said I want 1 replica. Now, why is that? You might think, hey, this is Kubernetes, we want 2 or 3 or 4, whatever. The reason I put 1 is, remember, it's always trying to have 1. So if it doesn't have 1 up and available, it will automatically create another one. The difficulty with PiHole and pretty much a lot of the applications you're going to find in the homelab space is they're just not designed to be able to read and write multiple times to the same database. So that means we couldn't have a database where we've got multiple applications all trying to read and write at the same time. That's a lot more complicated, and you'll see that in enterprise setups, but we're not going to get into that in homelab, and to be honest, I'm not even sure how to do it. So what this is going to do is it's always going to try and maintain 1 instance, and that's fine because you only need 1 PiHole. If that ever failed, it would then deploy it again onto the other node. So moving further down, we can see that we've set the node selector to be worker true, so it's going to put this on that node. And interestingly, this is a multi-container setup, remember, because we've got PiHole and we've got the Cloudflare D, that Cloudflare tunnel. So it's going to first deploy Cloudflare, and you can see here it's pulling the image. That's the same image we used in Docker, just in a slightly different format. I've called it Cloudflare D. It requires container port 53 and 57, just the same as Docker. It's going to have environmental variables of tunnel metrics 3000, so you can pull the metrics from this on port 3000 if you wanted to. It's then going to take some environmental variables, and you'll notice the indentation here. We've moved out again, so this is now for PiHole. So it's going to take time zone, web password, all of that other stuff, and importantly, it's going to specify the PiHole DNS to use the container we just created here. So this is exactly the same as the Docker Compose image. It's just in a different format. For PiHole, it's going to pull the image if it's not present. That's similar to Docker. It's going to use the latest image. And then these are all the ports that are simply taken again from our Docker example and put into Kubernetes. So 80 for the web interface, 53 for DNS, 443 if you wanted HTTPS, etc. The next bit that's interesting, and this is where we start to use Longhorn, is the volume mount. So this is going to give us persistence. And the way this works is it says, hey, I need some persistent storage. And in a minute, we're going to set Longhorn to be our default storage provider. So when it requests storage, Kubernetes is going to say, hey, the default storage provider is Longhorn. Hey, Longhorn, I need you to create some storage for PiHole. Now, unfortunately, I don't know a way of doing this automatically without it generating a really awkward long string for a name, which isn't very helpful. So we're going to manually create this mount within the GUI interface of Longhorn. Thankfully, it's just a few clicks and it's really simple, so don't worry too much about it. Then once it's done that claim, we're actually going to mount it to it. After that, we've got the service, and previously this was a separate file, but I've just baked it in here. And this is to basically say all of the ports that it needs in the deployment, we're going to set them up as a service so that it can serve them out to the cluster. So this is exactly the same ports, and at the bottom again, you'll see our good old friend, the load balancer. And this load balancer IP isn't where you're going to be accessing the web GUI. Remember, we're going to do this through Traefik with an SSL certificate, so it all looks nice and shiny. This is the IP address of your DNS resolver. So previously, you've probably set your DNS resolver to be your Docker IP. But in this instance, it's the same principle. You just want to change it to whatever this is, because Kubernetes with PiHole installed is now going to be your DNS resolver. Moving back to the PiHole folder, we've just got the default headers. Now this is exactly the same as before, however, it's just being put in the PiHole namespace. So it's an exact replica, just in a different namespace. Nothing to change here. The last thing is the ingress, and remember, this is basically what exposes the container. So it gets the external and then it creates an ingress to point external traffic to the service we've just created. And again, you're going to want to change this URL here to whatever you're using. I've just called it PiHole 3 because PiHole and PiHole 2 are already taken in my instance. Importantly, again, at the bottom, get used to this. You need to change the secret name to whatever yours is configured as, and you should be good to go. Now that I've talked you through how to configure the files, you're going to need this later, so bear this in mind. We can look at what the script does. So in the root folder, we've got the script. So this looks like this. So there's nothing that you need to configure in this. It should do it all for you. Firstly, step 0, it's going to clone my GitHub repository. And all of those files I've just told you to change, if this script detects that you don't have them already, it's going to pull them down and extract them for you. So you'll see that if it doesn't have that, it's then going to exit it. It's going to download, then exit it, and it's going to tell you, edit your files. So when you run this after step 0, go and edit your files like I just told you to in the previous section. Once you've done that and you've edited your files, run the script again, and obviously this time it's going to say, hey, that exists, move on. So firstly, it's going to check our dependencies. So it's just going to check that Helm's installed, it's going to check that kubectl is installed, and fingers crossed, that should all be there. After that, it's going to add some new repositories. Now it's going to add the Helm traffic repository because we want to install Helm. It's going to install EmberStack for Reflector, which is needed for CrowdSec, and we'll come on to CrowdSec in a later video. Then it's going to add the actual CrowdSec itself Helm, and then it's going to do a repo update. So just to be clear, in this video, we're not going to use these, but we're going to add the repositories for future videos. Next, it's going to create the namespace for Traefik. We know what that does. because we want to install Traefik in its own namespace. Then it's going to install Traefik with a Helm command. And the important bit here is it's going to specify the values file that I just talked you through. So because you've run this script, that values file is going to be at helm traefik values.yaml, and it's going to use that for the deployment. Next, it's just going to spit out some messages about how the deployment's going. So it's going to spit out the services and the pods that have been created. Hopefully 2 in this instance, or whatever you've set the replica count to be. Next, it's going to apply those default headers that we just spoke about, as well as the secret dashboard, so the password, as well as the middleware to be able to access this, and the ingress as well. Next, we're going to install Cert Manager. Now, if it detects that Cert Manager isn't installed, it's going to go ahead and install it, but because we've already done the Rancher installation, you should have it. In which case, it's not going to skip over this. It's going to redeploy Cert, and you'll see that there is a Helm upgrade here, not a Helm install. And it's going to take the new values that we just created. So if you remember back to the bit I was just talking about, that's where we specified things like quad 9 and quad 1 for our DNS resolvers. So it's just going to redeploy Cert Manager using those variables instead. Next, it's then going to apply the issuer. So this is your credentials, your secret, your API key. It's going to apply that to your cluster. And then we're going to get onto the bit where it deploys the actual certificate so it can go and pull it. And that's it. At this point, Traefik should be spun up. Let's Encrypt should be going off and pulling down your certificates. And those certificates should then be stored within Cert Manager. And those should be highly available within your cluster to both of your Traefik instances. So at this point, you should have Traefik well underway if you followed the instructions correctly. Next, really simply, once you've configured all your PiHole variables, it's simply going to create the namespace of PiHole, and it's then going to deploy the PiHole manifest files. And you can do that using a folder here, so you can do apply-f, and I've just specified a folder. So all of the YAML files within that folder automatically get deployed. You don't have to specify each one, which is really cool. So now I've talked you through how to configure all of the files. Let's actually see this in deployment. So to do that, I've gone over to my admin VM again, and I'm going to right click and I'm going to do a new, and then I'm going to do file, and I'm just going to call it deploy.sh, call it whatever you want. Again, you're going to need to make sure that you copy and paste the commands from my GitHub. So we just want to copy this in the background, paste it in, hit save, and then we want to make sure that it's executable. So right click, properties, make sure it's executable. Okay. Now that we've done that, we're in a position to run this script. So let's fire up our terminal and let's run the script. /deploy and hit return. Now the first time it runs this, it should pull down the repository. So yep, there we go. And you can see the message. Repo was cloned, edit the files. So if I do a refresh here now, we should have 2 new folders. Yep, we do. We've got Helm and Manifest. Inside Helm should be Traefik. Perfect. And these are all the files that you need to now go and edit before you can do this script again. Go back to the beginning of the video if you need to and edit those files exactly as I specified. If we go back to the Manifest folder, you can see PiHoles here with those 3 YAML files. Again, go and edit those in line with the instructions I just gave you. So I'm going to go and edit my files now, and I'll see you in a minute when we just need to launch this script again. So I've now edited my files, but as I mentioned, there's a couple of tweaks we need to make to our cluster before we want to run this script again. So let's head into Rancher and make the necessary changes. So now we're in Rancher, we want to head over to Nodes, and yours should look something like this. We've got 3 master nodes, 2 worker nodes, and our 3 Longhorn worker nodes. What we want to do though is actually to add some labels, because you saw in the deployment that I specify things like worker equals true. So that means that Traefik and PiHole will only be deployed on those worker nodes. So to do that, you want to click on both of your worker nodes. So I'll do number 4 as an example and just replicate this across all of them. We want to go to the top right and we want to click edit the config. Click on labels and we want to add a label. So all we're going to do in here is say worker is true, and also we want to put Longhorn true. Now you might be thinking, why are we adding Longhorn? That's because we don't want to use this for storage, but we do need to make sure that some of the components of Longhorn are installed on these machines so that it can dynamically be allocated space on Longhorn. If you don't allow the components, I think it's the management interface, to be installed onto it, it can't access the storage. So when you add these labels and you want to hit save in the bottom right hand corner, you can now see that on 4, if I click on it, after a few seconds, Kubernetes should realize that, Longhorn isn't installed on here, and it's supposed to be installed on any single thing that has Longhorn equals true. And here you can see it's the instance manager is being installed. Without this installed, it can't be allocated space on Longhorn and the container deployment will fail. So that's creating. So let's go back to the nodes, and we're going to assign the exact same labels to our other worker node. Now I have both of my nodes labeled, and crucially only worker equals true is on my true worker nodes, so pods shouldn't be deployed on anything else. Now that I've specified Longhorn equals true, as soon as those images have been pulled and deployed, that one's done in this instance. Let's see if number 5 is completed. Yeah, that one has as well. We should now be able to head over into Longhorn, and we should now see those 2 machines. So if I click node, you can see that I've got K3S05 and K3S04. Now those are my 2 worker nodes. So I actually don't ever want to schedule those. So I can tick both of those. I can click edit node, and I want to make sure that I click disable. So that means that volumes that are created, and we'll see one of those in a minute, are never going to be assigned to these devices. That means their storage is preserved purely for pods and deployments. It won't get used for storing volumes. The only things that are available are these 3 here, which we specifically designed to be higher storage, as you can see here. So any volume mounts are going to get created on these 3 machines. The last thing we need to do now, before we start the script, is to head over to volume and create a volume. And I'm going to call this one PiHole. I'm going to give it 3 gigs, and I'm going to hit OK. You can see that it's creating it here, and in a minute, I'm not going to do it now, although you could do it in advance, because I just want to demonstrate this in action. Now that's created, we're going to go back to the script, and we're going to run it for a second time. So this time when the script runs, it should say, fine, everything's already there, which it did, and it's gone on to the next bit, so it added all those repositories. It's now just installed Traefik, and you saw how quick that was, even on my rubbish internet, and you can see that 2 pods are pending. You can see that the IP address here, the load balancer was given 65, which is what I specified. Now it's going through and applying all of the challenges for Cert Manager, so in the background it should be doing the challenges to go and get your certificate. It's redeployed Cert Manager because it found that it was already installed and it needed to take those new variables. And we don't have any issues here, no error messages that I can see, and the script is finished. Crucially, at the bottom you can see that PiHole was created, the service and the deployment were both deployed. Brilliant. Let's head back into Rancher and see what's going on. So back in Rancher, it's all getting a bit crazy. We can see that we've had a ton of stuff started downloading, Cert Manager's been killed and then restarted again. We can see that it's scaling up certain things, but let's head over to the workload. Let's go to our deployments, and then fingers crossed at the bottom, we should have PiHole. Yep, that's deploying. Well, it's actually updating and it can't deploy because we need to go back into Longhorn. I'll show you that in a minute. Crucially, Traefik is there. Bingo. Let's have a look at Traefik. Both pods are up and running. Excellent. Now let's have a look at our certificate. To do that, we want to go into more resources and we want to click on Cert Manager and we want to click on certificates. The good news is the issuer is there and it's active, and you can see here that the certificate is unavailable. Uh-oh, what does that mean? Well, don't worry, that's because it's going away and doing a challenge. So it's setting that DNS record, it's waiting for it to be picked up, and in a couple of minutes, that should be ready. Famous last words. We could actually find the pod that's doing the challenge and check the logs. I might do that if there's an issue. Now, if we check on how PiHole's doing, let's have a look. So we're going to click on workloads, we're going to go to our deployments, scroll down, and you'll probably see that PiHole is still updating. What's happening? Well, if we click on it, you can see that there are no persistent volume claims available. So let's fix that by jumping back into Longhorn and assigning a PVC, so that's a persistent volume claim, to the volume we created. So clicking Longhorn again, let's go over to our volumes, and here you can see that it's detached. So if you hover over this button here, and unfortunately scroll down to create PV/PVC, we're going to leave it as PiHole, and we're going to put it in the namespace of PiHole. Then click OK. When we click OK, this should change in a moment. It should have a spinning wheel and it should start to say attach. Brilliant, it's saying it's bound, and it should attach any second now. So what's happening here is now PiHole has said, I want some storage, and now Longhorn said, yeah, here you go, you've got some storage, it's available to you. So now it's attaching and it's healthy, and now you'll see this actual size start to grow as files from PiHole installation get stored here. And if we click on the PiHole itself, you can see that it's replicated now across those 3 nodes, and we can validate that by clicking on the node, and you'll see that there's a replica on each of these. So that means the PiHole data is now saved across all 3 of these VMs. Perfect, we've got highly available storage. So now let's hop back into Rancher and see what the status of PiHole is. So now back in workloads and deployments, hopefully we've got a green PiHole, active PiHole, fantastic. So here you can see that 2 out of 2 are ready, and remember, this is a multi-container pod, so within here it's going to have the Cloudflare tunnel and PiHole itself. Both of those are up and running, and if you click on here you can view the logs and you can execute the shell just as you would normally. So now I should be able to go to my piehole3.jimsgarage.co.uk and see the PiHole interface. Fingers crossed, here goes. Ta-da! We've got PiHole up and running, and it's a one-click install, and it's using the goodness of our SSL certificates that we automatically deployed and pulled as well. So now you have all of the bare bones to start moving your applications from Docker into Traefik. Now, don't get me wrong, that's not going to be a straightforward process. But think about it this way. You've got your cluster set up, you've got your storage set up, you've got now multiple examples of how to deploy Helm charts. So find Helm charts for applications if you can, or create manifest files like I did for PiHole. Remember, you just need to follow the same set of processes. You need to create namespaces for each of these applications, so copy the template and just amend it for your applications. You need to assign some storage if you're expecting it to have storage. So again, you can copy and paste what I've got in the volume mounts and then create those volumes within Longhorn itself and just watch it automatically assign itself. And that's pretty much all there is to it for basic configuration. There are some things that we're going to go on to in the future. Obviously in the next video I'm going to look at GitOps in terms of how we can get away from some of these scripts and just have it automatically install. But in future videos I'm talking much longer term. We'll do some more advanced things around things like network security policies and all of that sort of stuff. But the Kubernetes documentation is really helpful. And hopefully you can copy and paste some of those commands and those deployments and you'll have things up and running like network security policies. So I hope you found that useful. There's a lot to take in there, so please go and watch the video again. Understand all of the steps, all of the changes, all the different types of configuration files you're working with here, because you're going to need those to deploy additional applications. Thankfully, the processes aren't too dissimilar to what I've just gone through. So it's a case of tweaking your existing Docker Compose files, putting them into the YAML format, and then deploying them with the same mechanisms that I've just shown here. Remember that all the commands, if you can't see them, should be in the script, so you can go and have a look at them. Plus, we've done manual installations of some of the things, so for example, Rancher itself. So now you've got your very own mini cluster, and you can start to plug in your existing Docker apps into Kubernetes. This took a hell of a lot of work to get here, so please do give it a thumbs up, hit that subscribe button, and let me know in the comments how you're getting on. And just remember, you can hop into the Discord if you've got any issues. There's a great bunch of people in there now and we're all helping each other out. So take care everybody, and I'll see you on the next video where we're going to be looking at GitOps.